Now, apart from all this process, so this module we have tried to get some overall view of the different fusion welding processes, their basic principle, their application area, limitation. But there is a welding overall subject, if it is a vast area. Now, we will try to focus on that. Of course, there are certain advantages, so much of development, some limitation also having, but here I try to summarize the few issues and challenges generally observed in the welding process. First significant point is that most of the fabrication industry, that means around the arc welding process, basically used more than 70% of the demand from the fabrication industry. So, that means most usually in fabrication industry, most usually welding process are the different variant of the arc welding process. This is the information. So, that several development of the arc welding process depending upon the need, area, applicability has been developed. Of course, if we look into other aspect, for example, that thermite welding. So, need of this welding process actually to apply in the remote area. So, there is no need of the electrical connection in this case. So, that is why this process has been developed from the application point of view, the basically joining of the railway track, there we can use remotely this process. So, in that case thermite welding process is more preferable, more usable. So, in that sense, of course, there are very precision or there are welding processes, but till arc welding process is mostly usable process in case of the fabrication industry, depending upon the availability or requirement of the welding process. Of course, cost is also another important factor. In contrast to that arc welding process, the other laser beam welding process, high beam energy welding process, for example, high beam energy process means laser welding process and electron beam welding process, that using this process also we can produce the very precise joint with the minimum defect, or where there is a difficulty of welding in the arc, difficulty of joining materials using the arc welding process. In that case, probably the high beam energy is the more preferable welding process. So, where precision is the more significant and cost is not the important, in that aspect probably the laser beam or electron beam welding process is more preferable. For example, aerospace industry, most of the cases the welded components are from the electron beam welding process, and that because electron beam welding process definitely it is a very costly process. So, that is a need, and each and every type of welding process having their own merit and sometimes having the demerit, their applicability area, and it demands on the according to the cost and their importance in terms of the accuracy of the weld joint finally. But of course, the one of the significant aspect in the welding of the high beam intensity beam is that excessively high concentration of the heat, but at the same times the rate of cooling is normally very high in case of the high intensity beam welding process. So, rate of the high solidification and the cooling is normally we observe in case of high beam energy process. So, that rate of cooling or solidification process that actually impact on the final weld microstructure. So, apart from that, there is another challenges in the welding process of the aluminum welding process. If you see the most of the cases in welding of the aluminum using the conventional welding process is not easy like other type of welding of the steels and ferrous materials. So, porosity in aluminum welds is the major challenge, because aluminum exhibits 20% greater solubility of the hydrogen in the liquid state at a high temperature, and that gas may be entrapped and creates the porosity in the solidified weld. So, that solidified weld that becomes the part. So, if we use in conventionally the other welding process, the welding of the aluminum, is really very difficult. So, we can expect that the probability of the formation of the weld defects will be more in case of the aluminum welding process. So, that is why not all the welding process is suitable for the aluminum welding process. Specifically, sometimes specific design, some modification of the welding process is required to join the aluminum. In final welded structure, even fusion welding process, the high distortion and cracks are also the other type of the problem. Here high distortion of the crack is basically we observe that the distortion is mainly comes from the coefficient of the thermal expansion, and if we observe that if happens during the solidification, after application of the heat, the molten metal and molten becomes solidified to the solidify, and the solidified structure can from the solidification cracking may also occur. So, that solidification cracking is mainly due to the if there is a large change in the volume, or basically volume shrinkage is very high during the solidification. So, that actually creates either solidification cracking or creates a large amount of the distortion in the final weld structures, or it can create the solidification cracking. So, that is another problem. Specifically, this problem is related to the large amount of the volume shrinkage during the welding process, and it depends on the typical properties of the material, the volume shrinkage. But if you look into this figure, right hand side, that it is a simply joining of the titanium alloy to weld, and we can see there is if plate is very high length. So, we can observe some distortion. So, that distortion also comes or that is related to the amount of the residual stress generated within the body itself, and finally, it creates the distortion. So, if we want to overcome this kind of problems, so definitely we need to know the structural changes after the solidification or solidification behavior, how it needs to study in detail to predict the solidification cracking or different type of metal. So, it is to more or less the metallurgical structure or changes during the welding process. So, this is different aspect. We will having one module to look into that metallurgy of welding processes also. So, in that process it is mainly how the metallurgical structure, it depends on the the rate of the cooling during the solidification process. But of course, distortion, solidification, cracking, this kind of problem will always be there during the welding process. Only thing is that how we can minimize this kind of problems of the different processes. Other issues of welding process is that basically the welding of the titanium alloy, and of course, titanium alloy using the normal arc welding process is really very challenging, because titanium actually at high temperature, titanium always react with the oxygen, nitrogen and hydrogen at certain temperature, and then molten weld pool must be protected from this atmospheric contamination till it cools down to the certain temperature. So, that is a real problem. So, it may not be too much severe in case of the welding of the steel, but welding of the titanium is a very difficult, because it easily react with the oxygen and hydrogen, and the oxygen becomes the part of the final weld joint. So, welds can contaminate it with the oxygen, and it actually creates the very brittle and hard. So, that is why to avoid the atmospheric contamination, most of the cases we do the welding of the titanium alloy inside a chamber, or some modification can be done when you try to do the welding of the titanium alloy, so that this oxidation problem can be at least it can be reduced. So, the one of the methodology of welding of the titanium alloy is that if we change simply using the fixture using for the welding of the two sheet plate, for example. So, here we can use the copper plate, and we can use the purging extra shielding gas. So, extra sealing gas actually comes from this small hole. If you look into this fixture, so that actually protect the titanium alloy during the welding process. So, this is the one of the easiest solution for welding of the titanium alloy. So, it's this type of extra arrangement of the sealing gas may not be required in the when you try to do the welding process, simply either plasma arc welding or tungsten inner gas welding process. So, that is why to protect it this oxidation problem to some extent in case of welding of the titanium. Another advantage, that means as compared to the friction welding process, there is a recently there is a so much of development of the friction state welding happens. This is the one kind of the solid state welding process, and if we see this solid state welding process, that here also the weld can be created in the different zone, that weld nugget in friction state welding process. So, let us see the what is the friction state welding process. Friction state welding process, simply two components are joined by stirring of the plasticized material. So, that temperature should be controlled in such a it should be well below at least below the melting point temperature. So, frictional heat is generated and the plasticized material is basically mixing and it finally makes the weld joint. So, typical characteristic of this solid state welding process is that it creates some nugget zone, and that nugget zone is basically defined by the certain temperature, thermomechanically affected zone, heat affected zone and unaffected base metal. So, to do these things we need the design of the tool is important to know here, that the different type of the tools, tool probe, cylindrical profile, taper cylindrical, having thread and square, threaded, triangular shape of the. So, these are the different types of tools can be used for the welding purposes. In the design of the different types of tool is mainly attributed to that material flow or mixing of the material can be ensured to expect a good weld joint. So, this friction state welding is the recent development in the solid state welding process, and nowadays people are also using this is also having so many advantages as compared to the fusion welding process. So, like that many problems of the fusion welding process can be avoided if you try to use this solid state welding process, typically the friction state welding process. So, there is no melting of the workpiece. So, the problems like the porosity, solidification, cracking and thermal distortion basically or almost physically non-existence. But only difficulty is that friction state welding process limitation is that if there is a insufficient material flow, then it can create some defects. But in general, the harder the workpiece, if the strength limit is also there, if the workpiece is very hard material, then the more stronger of the tool material is also required. And because the weld actually evolves simply as a function of the geometry of the tool, nature of the geometry of the tool, what is the tool rotational speed and what is the welding piece, what actually impact on the final weld joint quantity in the solid state welding process. But issues or challenges in this process is that, and challenge mainly if we find out that insufficient material flow, if we look into this figure that it is a welded joint, but we can observe some small gap. So, that means there is this happens due to the material flow is not good, then it can create this kind of problem also. Right hand side also it is a good weld joint, and that means in solid state welding process joining these two components. So, therefore, it is extremely important to identify the appropriate composition of the tool, appropriate combination of the tool geometry and the other welding parameters, tool rotational speed and also welding speed, that actually ensure the proper material flow. Then we can use this combination of the parameters and we can expect the good weld joint. But other side, the limitation of this process is that because tool experience the severe amount of the stress rotation. So, wear of the tools is very important of this, and cost of the tool also a very important matter in this process. And of course, this process is limited to up to certain, if it is very high hard material is very difficult to welding this process. So, still it is not commercially used specifically for welding of the very high hardness material. So, in that case the only solution is the fusion welding process, but few cases it is this process has been we can expect a good weld joint solid state welding process, and in this case the difficulties or having porosity and cracking, all these phenomena can be avoided this type of welding process, this solid state welding process. But another issues in welding process, that is called the friction welding of nickel based super alloy and titanium alloy. So, this type of welding material we generally use the friction welding. So, of course, the fusion welding of the nickel based alloy, super alloy and the titanium alloy is very much difficult because of their high melting temperature and at the same time high reactivity with the at the very high temperature. So, that is the limitation of using the fusion welding process, specifically the nickel based super alloy and titanium alloy. So, friction welding is the most efficient method by joining of these materials in very critical applications, probably in case of aerospace industry. Now, other welding processes, for example, laser beam welding process of aluminum and titanium alloy is another alternative method. So, laser beam can also be used welding of the aluminum or titanium alloy. We know the different type of the solid state laser and gas lasers are also there, and that laser beam can be produced the very narrow weld and with the minimum heat affected zone and high depth of penetration and small distortion as compared to the other arc welding process. So, in that sense the difficulty of welding aluminum or titanium in very conventional arc welding process, so that can be used in the laser beam welding process. So, probably for example, in welding of the titanium alloy, if we try to use the laser welding process, so extra shielding gas sometimes may not be required, probably the shielding provided by the laser during the laser welding process is sometimes is advantageous, or other way the welding can be done for these materials in a separate vacuum chamber. But mainly in case of that large panel fuselage, that means what is the main body of the aircraft is basically we generally apply the laser beam welding process. So, because simultaneous welding from both sides, that means path of the welding in this case is very important. So, if we choose proper path of the welding process, that means simultaneous welding from the both side, that actually try to minimize the distortion in a very large or spherical or cylindrical panels that used for the main part of the aircraft body. And electron beam, that is the another welding process, that is the electron beam, which is welding process, which is the mostly used in case of the aerospace industry. And that electron beam welding process in aerospace industry mainly used in a vacuum, and that actually ensures no gas contaminations, and that actually provide the very high depth of penetration irrespective of the type and the nature of the surface condition of the material, and this is very proven or widely accepted critical aerospace, widely accepted for the critical aerospace material. So, most of the aerospace components is used in case of used by the electron beam welding process. So, critical aerospace components such as gear, compressor, rotor, this type of component of the aerospace industry, they actually using the electron beam welding process, because here the defect free welding is the main constraint here. So, therefore, electron beam is the good solution for the one of the approved joining process specifically used for the aerospace industry. But one main challenge of this electron beam welding process is that there is a in electron beam welding process when you try to join the two dissimilar material, and because electron beam is the flow of the electron with a defined path, and there is maybe the thermoelectric magnetic field effect, and that actually better explained by the Seebeck effect. Because of that, the path of the electron beam actually get deflected in one side of the material depending upon the magnetic permeability of the both the material. For example, combination of the copper and steel, most of the cases the electron beam is basically deflected towards the steel material. So, it is very difficult to focus using this different combination of the material and exactly at the joint interface. So, that is the one of the difficulty of the or challenges exist in case of the electron beam welding process. Issues now, recent development also happens in the fusion welding process, that actually occurs in case of the so much of development happens the micro scale welding process. So, micro scale welding process is nothing but the reduction in scale of application and from the conventional welding processes. For example, the development happens so far in micro welding processes is that resistance welding process is basically scaling down in case of micro scale application. Arc welding, for example, TIG, MIG and plasma, these are the not exactly MIG, basically TIG and plasma is mostly developed the application in the micro welding cases, and the laser and finally, the electron beam welding process, that all scaling down to the micro scale application. So, definitely nowadays the specifically the different very small components in the very smaller scale when you try to join, then it is we generally use the different micro welding processes, and that micro welding process, say this typically micro welding process resistance, TIG and plasma micro welding processes, laser electron beam welding processes has been developed, but electron beam welding processes normally we use the electron beam welding process to apply the high density of the high heat generation, and the it is a very focused on small area and high depth of penetration. In that purpose normally we use the electron beam welding process, but in micro scale application the principle simply by modifying the scanning electron microscope optics, then the electron beam welding has been developed in the micro scale application. So, in that case maximum 6 watt power can be generated in the micro scale application, but most widely applicable or most preferable welding process in micro scale application is the laser, because laser can be very precisely controlled and powers can be scaled using the different type of the pulse. So, that is why laser welding is more advantageous in the micro scale application process, but main challenge of this micro scale welding process is that geometric precision, cost of the equipment is the main challenge, because sometimes we need to do the fixture, design of the fixture and handling of the small component, basically robotic arm can be used, and of course, if micro scale application sometimes we need the development of the whole welding setup under the microscope. So, in that sense the cost of this equipment or cost of the process becomes very high, and that is the main challenge of the micro scale welding process. So, with this several issues and challenges existing in the welding process, I conclude that first module of this basic fundamentals of the welding and joining process. Here I have tried to give some the basic mechanism, basic principle of the different type of welding process, different direction, advancement of the different types of welding processes also happen, and that what are the current issues and what are the current development in this welding process also happen, and that try to explain this module not in brief, but in the try to give some in the introductory level, but in the subsequent modules we will try to discuss in details about the different types of the welding process or different directions or the different development happens in the welding process. So, thank you very much.